So today's lecture is about the problems on separable kernel. For example, y of x is equal to lambda integral from 0 to pi sine of x plus t y of t dt. Okay, so here we have y of x is equal to lambda integral from 0 to pi sine of x plus t y of t dt. Now this is equal to what? Y of x is equal to lambda integral from 0 to pi. This is my separable kernel, okay? So what is sine of x plus t? Sine of x plus t is nothing but sine of x into cos of t plus cos of x into sine of t, okay? Y of t dt. Now y of x is equal to, this is the formula, okay, for this. This is the formula for this. Next is y of x is equal to lambda integral from 0 to pi sine of x cos of t y of t dt. So I will multiply this with this first, okay, with along with the integral, okay, and then with this. So lambda integral from 0 to pi sine of x cos of t y of t dt plus lambda, this I will multiply. So 0 to pi cos of x sine of t y of t dt. I'll turn the page. Now this is equal to what? Lambda sine of x. So the terms which are with x, I have to take it out, okay? So that's what I have done, is equal to lambda sine of x 0 to pi cos of t y of t dt plus lambda cos of x. So I have taken this outside x term, okay, with this. So integral from 0 to pi sine of t y of t dt. Now I have to consider this part as my C1 and this part as my C2. So y of x is equal to lambda C1 into sine of x plus lambda cos of x is there, and this is my C2. And consider this equation as 1. Okay. Next is what? Where my C1 is equal to this cos of integral from 0 to pi cos of t y of t dt. This cos of t y of t dt, integral of this, okay, and I have considered this as 2. Similar way, the C2 is my this thing, integral from 0 to pi sine of t y of t dt. This I have considered as my C2, and that I have written it over here, and consider this as equation 3. Next, using equation 1, we write 2 as, so I will be using equation 2. This equation I will use, and we'll write 2 as what? Now C1 is equal to integral from 0 to pi cos of t. Now we have used this part, okay, first this. So C1 is equal to integral from 0 to pi cos of t. Now what is my y2? I have to use this part, okay, as my y of t. So then write it down in the bracket, lambda c1 sine of t plus lambda c2 cos of t dt, okay. Then you have to multiply this with this term, and then this you have to multiply with this term, okay. This into this, and then this into this, okay. Now this is equal to what? Lambda c1, take it outside, integral from 0 to pi cos of t into sine of t plus lambda c2, take it outside, then integral from 0 to pi cos of t into cos of t is what? Cos square of t dt, okay. Next step is what? Next step is equal to, now this is equal to lambda c1 upon 2. Okay, so how I got this upon 2 and here sine of 2t? Now what is my cos of t into sine of t dt is what? Yeah, this is my rough page, okay, this. Let me write with some. So this is my rough page, okay. this is my rough page, okay? So what is my what is my cos of t into sine of t? See, 2 cos of t into sine of t was is equal to sine 2t. But then 2, if I take it down, what it will become? Cos of t into sine of t is equal to sine of 2t upon 2. So that's what I have done it here. 2 I have taken it outside here. Then 0 to pi sine of 2t dt plus lambda c2. What is it? Lambda c2 here. Okay, integral from 0 to pi. Now what is my cos square of t? Cos square of t is what? Now look at here. Yeah. 2 cos square of t is equal to 1 plus cos of 2t it was. If I take this to here, this side upon here, what it will become? Cos square of t is equal to 1 plus cos of 2t upon 2. Okay. So that's how I got this 1 plus cos of 2t upon 2 dt. Now this is equal to what? Write it as it is, lambda c1 upon 2. Now what is the integral of this sine of 2t? Is dt is equal to nothing but minus cos of 2t upon 2. And I have to, the limit is what? 0 to pi plus lambda c2 upon 2. This 2 I have taken it here. Okay. Next what I have done is, what is this 1? I have to make it as, it is with respect to, integration is with respect to dt, right? T. So that's why it is t plus cos of 2t is what? Sine of 2t upon 2. And it is, the limit is from 0 to pi. Now this is equal to what? Lambda c1 upon 2 I will get. Here I will get what? What is this minus will be for both, okay? Minus cos of 2 pi. 2 pi is nothing but what? Positive 1. Okay, see. I have given it here, okay? Cos of 2 pi is equal to 1. But then this minus was there already, okay? And then upper limit minus the lower limit. Minus cos of 0 is what? 1. See, cos of 0 is nothing but 1. But then this minus was for both. That's why it becomes plus 1 here upon 2. Now minus and minus 1 plus 1 is 0. So this term will become 0. So here lambda c2 upon 2, write it as it is. This is what in terms of pi. Minus 0 it will become, so this is pi. Then sine of 2t, sine of 2 pi is what? Sine of 2 pi is 0 and sine of 0 is also 0. So it's of, so what I will get finally? Pi minus 0. Okay, and this was only for this part, okay? This is t, okay, t it is. Okay, next is what? I'll turn the page. Yeah, I will get pi minus 0. So what is my c1 is equal to now? Lambda pi c2 upon 2. This part will remain because this part is 0. So what is my c1 is equal to lambda pi c2 upon 2. Now this implies what? c1. Then I have, if I take this term this side, it will become minus lambda pi c2 upon 2 is equal to 0. And you take it as equation 4. Then similarly you will be using 3. First we have done it using 2, right? Now we will use this equation. This c2 is equal to integral from 0 to pi sine of t y of t dt. So c2 is equal to 0 to pi sine of t. Now what is my y of t? Lambda c1 sine of t plus lambda c2 cos of t dt. Okay, that I have to take. And now what I have to do? Similar way, sine of t into sine of t is what? First what you all have to do is, now this c2 is equal to lambda c1, take it outside the integral, then 0 to pi. This is sine of t into sine of t is what? Sine square of t dt plus take this outside lambda c2, then integral from 0 to pi sine of t into cos of t dt. Okay, now this is equal to lambda c1, write it as it is, then 0 to pi. Now what is my sine square of t dt? Is nothing but 1 minus cos of 2t upon 2 dt plus lambda c2 upon 2. How it is? Sine of t into cos of t. Cos of t is what? Sine 2t upon 2, but that 2 I have taken it outside the integral. Okay, so plus lambda c2 upon 2 integral from 0 to pi sine of 2t dt. I'll turn the page. Now what I'm going to get is, this is equal to lambda c1 upon 2. Lambda c1 upon 2 I have taken it outside. Then what I'll get is t minus sine of 2t from here. The integral of this is what? T minus sine of 2t upon 2 I will get, and I will integrate this with respect to this. Okay, so t minus sine of 2t upon 2, and the limits are 0 to pi. This is the, okay, plus what? Okay, I can even do this as, I was supposed to write this as like this. Wait. 0 to pi, right? I'll do like this. Now, plus lambda c2 upon 2. Then in the bracket, this is the integral of what? 0 to pi sine of 2t dt is what? Minus cos of 2t upon 2, and the limits are 0 and pi. So finally of this and this, what I will get? c2 is equal to lambda c1 upon 2 pi plus, now this is what? Sine of 2 pi is 0, right? From here, yeah, sine of 2 pi is 0. So sine of 2 pi is 0 and sine of 0 is also 0. So I will write this in terms of pi, right? So that's what I did. Wait, and this, okay, this I'll remove. Okay, fine. Now that's how I got lambda c1 upon 2 pi plus the other part is what? Lambda c2 upon 2, write it as it is. And then cos of 2 pi is what? 1. So it is minus 1, and then cos of 0 is what? 1. But that minus and this minus will be plus. So minus 1 plus 1 is 0. So this term will become, the entire term will become 0. So minus 1 plus 1 I am getting, so this entire term will become 0. And finally what I am going to get is, this I will draw, okay. Finally this implies that C2 is equal to lambda C1 pi upon 2. So this is what I am going to get. C2 is equal to lambda C1 pi upon 2. Now this I am going to write it as lambda c1 pi upon 2, this, and this term I will take it to other side, so it will become minus c2 is equal to 0, and consider and take this as 5. Next is, we have two solutions now. What is this? This I have taken it from like 4, right? From here. Yeah, c1 minus lambda. So I have taken c1 minus lambda pi upon 2, c2 is equal to 0. c1 minus lambda pi upon 2, c2 is equal to 0. I have taken it here. And then this is from 4 and this is from 5. This lambda pi c1 upon 2 minus c2 is equal to 0. Lambda pi c1 upon 2 minus c2 is equal to 0. Now to get non-trivial solution, what I have to do? D of lambda is equal to 0. Now we have to find the lambda value. Okay. So d lambda is equal to 1. This is what? 1. How I got this 1? This is my C1, C2, coefficient of C1, coefficient of C1, then again, wait, I'll tell you all. This how I got. This is from here. And this is my C2. Minus lambda pi by 2 here. Minus lambda pi by 2, C2, okay. So this is my C1, C2 of the first thing, whatever I got. And then this second part is what? Lambda pi upon 2. Lambda pi upon 2, and then this is minus 1, the coefficient of this 1, minus 1, which I have taken it here. Then 1 into 1 is minus 1, 1 into minus 1 is minus 1, plus this is what lambda into lambda is lambda square. See, we have to do this minus this, but minus and minus will become plus. So lambda square pi square upon 2 to the 4 is equal to 0. Then what I am going to get is lambda is equal to plus or minus 2 upon pi. Okay, after solving this part and all. Like how to solve this part? Let me do it here. Here what I'll do is lambda square pi square upon 4 is there, right, is equal to, if I take this minus 1 this side, it will become plus 1, positive 1, right? And this 4 also I'll take it up, so that it will become lambda square pi square is equal to 4. So let me do it. Lambda square pi square is equal to 4. Then lambda square is equal to 4 by pi square. So if you apply root for that, if you apply this root, if you take it this side, lambda is equal to root of 4 upon pi the whole square, root of this, okay. What I'm going to get is lambda is equal to 2 by pi, right? So here what is the root of 4? 2, and this lambda square, this square will go. So I will get this 2 by pi. Therefore lambda is equal to 2 by pi positive, and lambda is equal to minus 2 by pi. Now what I have to do is put lambda is equal to 2 by pi. From 4 and 5 we get C1 is equal to C2, which implies that infinitely many solutions. Now this y of x is equal to what it was, and it was from what equation? Equation 1. From here I got this. Of x is equal to lambda c1 sin of x plus lambda c2 cos of x. So wherever there is lambda, plug this 2 by pi, and this c1 I have made it because c2 is c1 is equal to c2. So wherever c2 is there, I have put c1. Then take c1 common, okay, and 2 by 2 upon pi, 2 upon pi, take it as common and write it here, is equal to 2 by pi. C1 I have taken it common, then sin of x plus cos of x I will get. Then put lambda is equal to minus 2 by pi in that same equation 1. And here from 4 and 5, same thing, C1 is equal to minus C2 I am getting. And then plug wherever there is lambda, I have to plug here. And then what I have to do is 2 by pi I have to take it as common. C1 also I have taken it as common. Then cos of x minus sin of x. So here I am done with this. So I'll end up my lecture here. If you all have not understood any of the concept, you all can comment below. Thanks for watching.